Welcome everyone. If you want to sit down, there are a load of seats down the front. We've got deck chairs if you want to have a bit of a layback, or we've got nice comfortable seats up here, as well as some weird lumpy stool things. Welcome everyone to Expedia London, and to the first Expedia Affiliate Network Developer Network evening thing. I don't know what this is, and it's logo, so you know. We've got a really interesting lineup of speakers. We're starting up with Matt Biddulph. I'm being told people at the back can't hear me. Better? So we're starting off with Matt Biddulph talking about prototyping apps using real data. Then we've got Roberto Di Feo talking about natural language processing, and we're going to finish the night off, hopefully, if he gets here in time, with Gary Gale talking about lots of interesting geo stuff and maps and things. It's really good to have you here. I hope you've all enjoyed the food and the booze and things so far, which will be kicking off again in about an hour and a half. But now, without much further ado, Matt.
Thank you. How's the... Oh, that's how good that is. How's that? Can everyone hear me at the back? Yeah. Excellent. All right, hello. Hello. Hey, how's it going? Right, so thank you very much, Steve, for the introduction. Very happy to be here and talk to you a little bit about data. So, a couple of years ago, I joined Nokia, and I went to work in Berlin, in Nokia's, what do they call it these days, Location and Commerce division. Been through several reorgs since then. And my job there was to develop ideas for new applications with a product development team, and to try and create things that we could take to a product manager, to someone with a budget, up to the Nokia board, and show them, here's something we think is really interesting, give them a flavour of what that product was going to be like, and get them to buy into it with something in their hands, rather than just sort of made-up dreams. So I'm going to talk about some of the techniques that we use there, and some of the things that I've done with data since leaving Nokia, that I think translate into everyone's projects that are data-driven. But first, I have a message for different sorts of people in the room. Who here is a designer or a product development person, that kind of thing? Okay, a couple of designers. And who here is a developer? Build code, work with data? Okay, a lot more developers in the room. Okay, well, let's start with the designers. So, you know, wireframing. When we start to put together an application, there is always the stage when we don't know what the application is going to be like. And at this point, we make shit up. We have these wireframes. They're full of lorem ipsum. There are placeholders for what the information really is going to be. The names are John Smith, Jane Doe. Everything's nice and convenient, and we fall as designers into sort of patterns of imagining that the data is going to be perfect, and everything is going to, the line breaks are going to work out perfectly. The pictures are all going to look nice because we just picked out some pictures of our kids or whatever and stuck them in. Everything is going to be a correctly trimmed headshot of a person. And everything ends up being a little bit fake, and it doesn't feel as right as the final project does because it's lacking realism. So, every designer in the room, no more lorem ipsum, no more fakes in your wireframes. We're going to work with the developers to fill your wireframes with real data, or fake but incredibly convincing data. Developers in the room. This isn't an app. This is chart junk. We play with data, and it's super interesting. You can dig into whether it's Apache logs of how web traffic is performing on your website, or social graph analysis, or any number of fascinating machine learning techniques. Throwing it into a chart does not make a product. And it alienates normal people, and it can alienate designers. So developers, we need to work together with designers to create data that's actually usable in designs. And how are we going to do that? Well, it's prototyping. Getting to code as quickly as possible, but making sure that that code is not something that's siloed from the design process. So I like to think of, and my head is slightly in the way of some words, I like to think of prototypes as boundary objects. A boundary object in a sort of sociological theory is the idea that there are things that cross over multiple domains that get us away from our individual disciplines. When we've got a prototype for a product that we think is going to be great, when we've actually got it running on a phone in our hands, or we're showing it and it's not a click-through pre-canned demo, then we've made something that designers can start to tinker with. Okay, well, that doesn't seem to fit the idea I had in my head of how that data was going to fit on the screen. Or, oh, that suggests a new kind of interaction, something new we could do for the users. Developers can start to figure out, okay, so these, we're going to have these kinds of interactions. That means there's this kind of performance constraints on the code I'm going to build. And I'm a firm believer that really, really early on, we've got to get to the code and build a boundary object that connects together all the disciplines in the teams that make products. And hopefully from that, we'll get as quickly as possible to getting the money, getting the green light. And this was what we did in our team at Nokia. So I want to give you a little example of a little bit of data exploration that I did early on in a project, so we could explore the kind of data that we had at hand, and so that we could make sure that we weren't just making assumptions about the way users were going to use our data and the way the data was going to behave when it ended up in the product. So, Nokia has maps. They spent an awful lot of money mapping the world. They bought Navtech in an acquisition of something like $8 billion 3 or 4 years ago, and they put a lot of money into them, along with sort of Apple and 1 or 2 other companies. They're really the only people still going up against Google Maps as a sort of creator of data sets, provider of data, and people who make actual applications on top of that. So every time someone uses maps on a phone, they're telling you something about how they think about the world. You are expressing a need every time you pull your phone out of the pocket and say, I want to get somewhere, or what's the name of the street I'm currently on, or how long will it take me to get from A to B. Every time someone does that with a phone, they're telling you something about how they think of the world. And the interesting thing is, by building a maps application, you can create all kinds of other maps of the world. And let me explain what I mean by that. So, if you take, and this is an old screenshot. Excuse me, old screenshot. They've rebranded a little since then. It's looking a little more beautiful. But if you imagine any Slippy Maps application, any place in Google Maps or anywhere else where in a browser or on a phone, you see a map and you can move it around with your finger or with the mouse and find the things you want to find. As most developers know, the way that's implemented behind the scenes is there's what we call a tile server. The tile server the tile server splits up the world into many megabytes, gigabytes, even terabytes of images, splits them up into different zoom levels, and reassembles them in a JavaScript application or a native application on a phone to make the mapping experience that we're all used to. Every single one of these tiles, in every map you've ever seen, has come from a tile server. Every tile server is just a plain old web server, actually. It's just a server full of images. And so every one of those servers has logs. Now, if you go to the logs of that server and you find how many times has each one of these tiles been requested, how many times has it been on a screen somewhere in the world, you end up with a slightly different map of the world. So this is Los Angeles. This is what Los Angeles looks like cartographically. But if you analyze the Apache logs from the servers that serve up those tiles, create a heat map of how often each one is displayed over a given time frame, then we have this. So this is a map of the attention of Los Angeles, rather than as well as the shape of Los Angeles. You can actually see, I always use this as an example because Los Angeles has more than one city centre. It has a downtown area, it has Venice Beach, it has the airport, and it has Hollywood. And they're all big hotspots for attention for different reasons. So we're looking at the server and analysing the logs and doing something very mechanical, something very developer-oriented, writing jobs using Apache Pig and running it on a Hadoop cluster, and going off for a couple of days and generating data that really just looks, at best, like some of the chart jumping. I was able to produce this, which is something we can look over, we can annotate, we can say, okay, right, this is another part of the shape of Los Angeles. What products might start to emerge from that? But then you can start to interrogate the data a little more. What if we widen that up? If we go to another application, not the viewing maps, part of the experience, but the routing. Every time someone has asked for a route from A to B, and we see where do people in cars using the routing mode of their maps application, where do they go? When we get this heat map, it's different. So this is a map of people in cars in Los Angeles who don't know where they're going. They had to ask their phone, and the phone said, oh, you know, take this major road here. They stick to the major roads. The entire hipster area of Venice Beach is completely missing because, frankly, people driving in cars using Nokias are probably Finnish business people in Los Angeles, not locals. They wouldn't be asking for routing directions for their car if they wanted. So you end up with this completely different map of LA. This is still, for me, even though it's, you know, it's pretty, it's got colours, this is still the chart junk stage. But it's something we can start to use to build on, start to discuss what is the shape of a city when we make a mapping application. So when I left Nokia, someone said to me, you know, you work with data, you're a back-end server-side data analytics person. Aren't you going to miss all those incredible data sets? You know, the Nokia, you know, whenever someone is navigating, going in a car, using a Maps application, there's a GPS trace taking them every 5 seconds all day. It's anonymized and the IDs are scrambled and you can't trace anyone. But you end up with absolutely millions, billions of GPS data points per day. It's really, it's a fantastic resource. And you can ask it so many questions. It's really, through their phones, people are taking a vote on all kinds of questions about the world. And you can ask those questions through the data. So was I going to miss this kind of data when I left Nokia? Well, it turns out the internet is full of data. There's data just lying around all over the place. Tons of it is free. Tons of it is already formatted into some kind of way that you can use, whether it's implicit in streams of data, social media data, that kind of thing, or whether it's explicit in data sets you can download. So let's look at a couple of data sets and see how you might extract meaning, extract this intention of what people thought they were doing with the world when they navigated through it, tweeted about it, wrote things about it, and how we can extract data from it that we can feed into wireframes to replace the lorem ipsum and think about the shape of our future applications. So, realistic cities. Say you're building a social application, you want a set of how do people move around town. So whether that's because you want to do test some ad targeting algorithm, or whether you want to test some kind of model for how you might build a new check-in app or a new sort of social meetup, anything you can think of, it'd be great to have a big database of, here's a ton of users, here are the latitude and longitudes they move through as they sort of use London throughout the day. And I can use them to inject life into my prototype and see how people would respond to the kind of data and interactions that I want to build. So everyone's seen these kind of tweets, right? They go by all the time. I'm at wherever with some people, and there's a 4sq.com URL. It turns out if you click through to one of these individual tweets that says where they are, there's a lot of data in there. And furthermore, it turns out that if you click through, each individual check-in that anyone has done on Foursquare has an individual page that describes everything about where they went. It further turns out that if you write a script to track 4sq.com just as a string that occurs in tweets, there are about 35,000 of these every hour. So you can scoop these up and use them as a representation of how do people move around town. So I let this script running for a couple of days, gave me about a million or so tweets of where people had been, put them onto a Hadoop cluster that I fired up. An EC2 cluster using Apache Pig on top of Hadoop, got all this data about where people had been, grouped them by what their Twitter account was, and that gave me a bunch of realistic people, real people that had done actual stuff around London, but I could build into a little bit of a project. So, to be specific, I found someone, they'd done a series of tweets within the same half an hour or so. And what have they done? Well, they landed at SFO in San Francisco. They said they were at a gate. They went to the American Airlines Atmos. Then they got on the air train, then they got to the rent-a-car, then they dropped into a 7-Eleven. You can see how, straight away, if we show this, and we talk about this in a meeting, if I talk about this as a developer in a meeting with some designers, we can start to tell a story. This is a person who did a thing. Immediately, I've got a persona. I've got something I can drop into a design, and I've got a boundary object, a piece of real-world information that we can start to discuss and start to build out how products might work for these sort of people. So we picked that data up, just scooped it out of Twitter. It was just lying around there in public, and turned it into a data set. But even more importantly, this is a huge and as long as we want to keep gathering tweets from Twitter, unending data set. We can actually fill, if we gather this data for long enough, for days, for weeks, for months, we can actually simulate what a social app, a social geolocated app would feel like with 1 million users before we get to ever having 1 million users. And I think this is my first sort of major point about this when you're thinking about the development of a project, is that it's really, really hard when you're developing something new to imagine what it's going to be like when your design is filled with 1 million people. And it's very, very hard as a developer to imagine what the database load is going to be when your algorithms and your architecture is full of 1 million people. But if you scoop up this data from Twitter that actually behaves in realistic ways, that has all the sort of anthropological and social connections between people and place embedded in it, it's not just lorem ipsum, it's not just some imagined perfect data that you made up. Then you can make a sort of staging server implementation version of your prototype that's filled with 1 million users and actually show people what it's going to be like, test some things that you will not normally get to test until you're at scale. So, ranking. One of the, I think, most overlooked but most convincing, if you get it right, things about applications is when they get your data in the right order. Let me just give you an example, a bad example, that I found actually when looking for what I thought would be a positive example that we could try and emulate. So if you go onto Yelp and you do a search for a thing near a place, you click on area and it turns out they just list all the areas in London in alphabetical order. It's really it's actually pretty inconvenient. Because Aldgate and Alexandra Palace are probably much more likely to be a destination for social activity than Abridge or Addleston, which actually I don't think I've ever heard of. But I assume they're in London somewhere. Wouldn't it be more interesting if this was actually in correct sorted order and it would feel human? It would feel more human if places like Angel and Camden and Westminster were nearer the top, because they're the places that are more important to people in their social life, in their life of looking for restaurants and pubs and so forth. So it turns out that Wikipedia publish their web traffic statistics. And why is that important? Well, every place in London has a Wikipedia page. In fact, pretty much anything in the world that matters to enough people has a Wikipedia page. So if you know how many times each Wikipedia page has been looked at, that's like being able to ask the internet to take a vote for you on what's best in pretty much anything. What are the best movies? What are the most important politicians? What are the most interesting parts of London? They will just tend to be, to some order of approximation, the same rank as they end up in the Wikipedia page traffic statistics. Now these stats are huge. This is a snapshot of 7 months of the hourly page views. So every hour they just say, here are all the pages on Wikipedia, and then a number giving you how many times each of those pages was viewed. And 7 months of that data is 320 gigabytes. But luckily, someone, I think a guy at LinkedIn who's used it to refine all sorts of algorithms that they create, has already uploaded it to the Amazon S3 dataset service, which is a set of pre-canned read-only datasets that any Amazon Web Services cloud VM can mount as a disk. So anyone who wants to use this data can actually, it's 320 gigabytes of data, but you don't even have to pay to use it, because Amazon only charges you for bandwidth that goes outside of their cloud. So you've got this enormous amount of data, you can go analyze it. So I started up 4 M1.small instances. So 4 EC2 VMs, installed the Hadoop distribution on them with a script that does it all in one command. And in 4 hours, for about $10, I just like showing the numbers on this, because, you know, they're big. 500,000 records, just shy of 1 billion pieces of data about what the internet thinks about all the things. I can process all that in 4 hours. If I've got a bit more money, if I've got 4 times as much money, I can have it in 1 hour. So you can start to think about questions around what is interesting in the world and ask Wikipedia to take a vote on it for you. So I asked Wikipedia to take a vote on all the bits of London. And it turns out Hackney is the best. So, just to settle all possible arguments. So yeah, this was just over a period, I think this was February 2012, the whole month of views on Wikipedia. I've got Hackney had 3,428 views. and it goes on and goes on, so on and so forth. Not only is this a good ranking, because you can use it to say, okay, yeah, Hackney's at the top, and you should maybe show the bits of London in this order. You can actually use it for all kinds of ranking and scoring algorithms. So one of the demos that I built in this, and there'll be a URL right at the end that I'm sure we'll somehow manage to distribute. Everything I'm showing you in this talk, there's code for it on GitHub, and you can download sample data sets. I built a little autocompleter using this, and it's a weighted autocompleter. So if you give it, for example, you can find out what are the best Chinatowns in the world. You start typing China, and China is better than any Chinatown. But once you hit T, New York Chinatown is above any of the other Chinatowns, San Francisco and Los Angeles and so forth. So by building this autocompleter and loading up the rankings, the weightings of each thing in Wikipedia, you can start to ask all kinds of questions. And that autocompleter is something, it's just a JavaScript-based thing in a website. Anyone who can type on a keyboard can type in some things that might be in the application that you're building, something from any domain, and it will tell you what Wikipedia thinks about it. So it's incredibly useful to start building up wireframes that have realistic ranking of the items within them. Okay, realistic social networks. So I'm one of the co-founders of a little travel site called Doppler from a couple of years ago. And you know, it's the nature of building a specialist social network just designed for people who travel a lot, that you don't straight away end up with 300 million users. But you hope that one day you'll have 300 million users, but your growth curve is definitely not the speed of a Facebook growth curve. So how can I imagine what it's going to be like? Test my designs, test my algorithms, think about the new possible products that are going to be achievable when I have my data at massive scale. How can I build a social network that has 1 million people in it and has realistic connections between them? Well, again, you can write some sort of script to generate random names based on perhaps some theory of social networks from some of the anthropological or social papers out there. You can just generate randomized test data, which will never really realistically model the way the real world looks. Or, again, you can turn to Wikipedia. So, as I said, Wikipedia contains most of the things in the world, the things that are interesting. But also, of course, it's absolutely full of links between those things. And if you look at any one page of a person on Wikipedia, you'll see that it's full of links to other people. So it would be realistic to take the social graph of Wikipedia, to take the structure, to find every place there's a person, and say, yeah, if they mention another person on their Wikipedia page, that's a link in the graph. So there's a great project called DBpedia. What DBpedia does, it takes the plain text of Wikipedia, which you can edit any page on Wikipedia, and the content is all Creative Commons licensed. But as any developer knows who's tried to play with Wikipedia, the actual text, like the wiki text, the wiki markup, it's a bit of a pain in the ass to process. And then when you have processed it, then you have to work out, okay, what's my database schema going to be for this, and how do I store all the interrelationships? What's the difference between a sidebar and a section and so forth? What DBpedia has done is they've created a sort of a taxonomy for all the kinds of linkage and all the kinds of thing in Wikipedia. And they've made a data set that's just a really, really huge text file. And in that text file, every line is something like this. So there's a line that says, Bill Clinton is spouse of Hillary Rodham Clinton. Bill Clinton is starring of, so all the TV shows and movies that Bill Clinton is mentioned in or stars in have been extracted in that way. So you can take any subset of the sort of meaning in Wikipedia, like being a spouse of, and extract just those links. When you've extracted just those links, you can say, okay, what would that mean if they were just friends on Facebook? And this is what you get. So this is the social graph of Wikipedia. These are all the people on Wikipedia who are mentioned 250 or more times anywhere on Wikipedia. And every time that another person is mentioned on their Wikipedia page, a line is drawn between them. I ran it through some algorithms that are designed to detect sort of tight structure in a graph, any place where a lot of people are very connected to each other, but less so to anyone else, and use that to colour them. And actually, again, intuitions start to come out of the data when you start to talk about it. So it turns out politicians and royalty are a big area. They tend to sort of Politicians and royalty, as you'd expect, tend to be sort of interweaved. They mention each other in their pages. But there are more interesting ones. Look, tennis. Turns out there's a big island of tennis. Everyone on Tennis Island is only talking about other people who play tennis. There is almost no connection between tennis and the rest of reality. And within Tennis Island, there's the men and the women. And they're really separated out because of the structure of professional sport and the way that men and women's tennis separate out. Professional wrestling. Oh my god, it's so good. So every beef between Stone Cold Steve Austin and Randy, I can't remember his surname. It's called Randy anyway.
Savage.
Randy Savage. Thank you. It even turns out there's Japanese ultimate wrestling just down there in its own little section. And there's all kinds of other things in here. Oh yeah, comic book characters. Turns out there's pretty much any character who's ever been in the comic book is mentioned on Wikipedia, and all the interconnections between them are detailed. And if you zoom into it, you find that one end is all DC Comics, the other end is all Marvel. The people in the middle are like the, sort of the writers that tend to work for both of those comic book companies. And so, as you can see, we end up here with a social network that I can talk about with you without talking about data. I can talk about it in terms of stories. I can say that Superman is not very connected to Spider-Man because they're not in the same universes. And I really have to warn you, this is probably the nerdiest slide I've ever created, the next one, or at least given how much time I took to create it. So I created this wireframe to demonstrate the difference between our lorem ipsum wireframe and a wireframe about a product that's filled up with data that actually comes from the real world. It's called LinkedIn. It's a social network for comic book characters. It contains news about how supervillains create social media campaigns. But things in here, apart from a few little tweaks to the news headlines, it all comes from actual public data. People you may know. So this is Batman's page. The people you may know generated directly from the interlinks between pages on Wikipedia. So I can tell stories about this, and I can stand in front of a room. If I'm not too embarrassed, I can stand in front of pretty much any room and describe what this product is. But I can walk through, we can click through and see actual realistic connections between all the people in the wireframes. Everything in there would have something that relates to some human experience of the people who are looking at a prototype. It gets away from prototypes that are just filled with names of your friends, pictures of your kids, and lorem ipsum where there should be descriptive text. But if everywhere we just take a real social connection from the data in Wikipedia, a real ordering of data based on the vote the internet took about what matters to them the most, and we take people behaviour from actual people behaviour that's documented, they've in some way released in public, tweeted about, then our prototypes will be living things. They'll be convincing. There'll be something. They'll be emotional. There'll be something in there that your viewer, your audience can always relate to. And hopefully, we'll all make better prototypes. We'll all get our projects greenlit, and we'll all make awesome things. So yes, you can explore that graph yourself. I know it's hard to squint at without the labels on it. There's a big ass PDF that you can download and zoom around. And all the code that I've mentioned here comes from a much longer workshop that I did at the WARE conference a couple of months ago, and it's all up on GitHub. So hopefully we'll find some way to distribute these URLs, and you can have fun and make this stuff better. But until then, thank you very much for your time.
Well, I'm going to be looking for Batman on Facebook next. So, I don't know about you guys, I really enjoyed that. It's going to be a bit whistle-stop. We've got Roberto Di Feo